Alright, let's begin. So for this video, we're going to be covering sliders and radio buttons. Quickly, I'm just going to showcase the sliders. So this version, we have slider by groove. So as you can see, whenever I press the mouse, it will clamp to the slider. If I were to let go at the maximum, it registers the other canvas to the scene. If I move it to 0, it deregisters that canvas. So that is using this groove updated call, which is called whenever the mouse is released using the groove update strategy. So whenever we reach a 0, if the canvas is connected, disconnect it. If it's not connected, connect it. The alternative is to do it by percentage, where if I were to run this again. So now, instead of clamping to the grooves on release, I can just put it wherever I want. And for this version, whenever I reach 0, that is when I have my canvas connected. And if I go back to 100, it is no longer connected. So this version uses the percent strategy, where it will be using a percentage float instead. And when that percentage is 0 and the canvas is not connected, we connect it. And if it's at 1 and it is connected, we disconnect it. To discuss radio buttons, I have the particle demo to showcase again. So as you can see here, we have our particles exploding in all directions, as well as percentage-based sliders. If I were to adjust the X value over here, currently we have the X radio button pressed. If I were to increase this, you can see that now the X rotation is only in the positive direction. I can then move over to the Z to update the Z. So if I wanted all of these to be negative instead, I can adjust this slider to move them all to be negative with some randomness. And then if I were to go to Y, I can do something in between to just do something like this, and that is that updated the Y. If I want to just be a bit more extreme to showcase that it still works, then all of these store their values. So for the radio button group, where is the for the rotation radio button group, they have minimum and maximum sliders associated with the X, Y, and Z. Whenever one of the buttons is pushed, that registers the canvas, the X minimum and maximums to be entered. Whenever it's released, it stores those X and Y values for it, the minimum and maximum values, and we do that for all X, Y, and Z. For how radio buttons actually function, radio buttons come in groups. So we have null radio buttons, which act as a null operator for the last down button. So if we go over here, if the user submits entry and does not define what the last push button is, because radio buttons act on release the prior, push the next, we set this null radio button to do nothing when it's not defined. So when the user presses something, the prior release will have no crash. If the user does define something, then instead of setting the last button to be the null button, we just set it to be whatever it is in the array. Setting up, down, and updating text is similar to check buttons, where we static cast to find the location in the array and then call the set on that button. Setting the position, we loop through our active count and we update the position appropriately based on the height. For setting the active count, we just pass in an integer number, and then we have to update the position whenever we do that. This will crash if we do not have more than one radio button, if the number is greater than or equal to the maximum count, or if the last push button is not within that active count. For the first one, radio buttons, again, have the push-release mentality of both of them need to happen. So if there's only one button and you push it, there's no way to release it. If you do anything greater than the button count, you're going to fall off the array. And if you remove the last button from the active count, then it would release something that is not registered. So you always have to make sure all three of these are true when you wish to do that. For drawing, we just loop through similar to the check button. We go down vertically, decreasing the Y value, and then rendering. All of these are pass-throughs by the attorney, so we have the rendering for radio buttons as well as engine push and engine release, which are handled by the check UI press. So this is once again similar to check buttons. Loop through the entire active count until you find a button that is pushed or you exceed the count. When you find something that is successfully a mouse click on that button, you get the index of the prior button and then the button index of the new button. If the last index is not the same as the current index, then that means you have a successful click. If these are the same, nothing should happen because you can't unpush a radio button. The only way to release a radio button is by pushing a new one. So once we know these two are unique, we will release the last index and then update the last button to be at the current pointer, and then we will push the new index. And then submitting exit is requesting the deregistry and removing canvas. Destructor is deleting the entire array of radio buttons and then the null button. For sliders, sliders are composed of ends, which are the curved parts at the edge that the tick can't pass, segments, which is where the tick can move around over, and the tick itself, which is the movable part of the slider. Sliders do not have any button parent class. They are deriving directly from UI, so they are where you can set the textures and get the position updates and all that. You can submit entry by groove or by percent. Submitting entry by groove forces the clamping whenever you release the mouse. So for defining both groove and then for defining percent, that is where you will not have any clamping, and that will just return values relative to the percentage of the slider to the left. So for both of them defining the groove positions, we have the first position and last position of a vector array being negative and positive infinity. This is used for calculating nearest groove. Once we know that, then we can loop through our segment count, which is defined here for the length, and then define the x offsets based on the width of the segments and the ends. Real quick, for crashing for grooves, we have to make sure that the length is more than 1. Both the slider by percent and by groove need something greater than 1 here. Otherwise, there's nothing to update. It will always be on the same groove. And then the groove that you want to start at has to be within the range of that length. If you ever do something off that, then it will go out of bounds. By percent, rather than having it be a value less than the length, we just have to make sure it's less than 1.0 because this is going to be returning a percentage. So this is something between 0 and 1. Same determining of the groove positionings here. Setting the position. Anytime you set the position up or update the scale, you have to update the groove positions, which will just go through that vector and update all the positions, because that means each of the grooves are now at a new position. When you scale it, that means it's going to either move to the right or left. When you update the position, it's going to be in a new spot altogether. So you end up updating it here with the update call. Updating the text for sliders. They still follow the buttons ruling of the text being in the center right of it. So we update it to be in the center of the slider and then to the right of it. For calculating the groove, you have to loop through all the groove positions and compute their distances. Whenever you find a position where the distance increases, so you just loop through subtracting the tick's position from the given groove position. Once you find an increase, you found the nearest groove, so you break it out and you return the index -1. And also, because this is by groove, you set position to be at that value because you always clamp to grooves. For calculating the percent, you just take the tick position, subtract it by the first groove, and divide it by the width. It's a lot more straightforward. So that is how you do that. For the process, sliders care about the check press, check down, check release, unlike radio buttons that only care about check press. So for check press of the slider, it does what the held button does, where it sees if the mouse is hovering over any part of the slider. If it is, then we can start updating the tick. During mouse down, it will update the tick's X position to be wherever that clamped X value is. This clamped X value is just relative to the first groove and the last groove on the segments area. And that will keep going until you do release. So when you release, if you were updating the tick, it will call its current strategy, be it groove or percent, which both have their pass-throughs to call the right calculate formula via an attorney. Calculate percent over here, and then calculate groove over here. And that is how the release is done. Drawing it, you end up taking the end, drawing it, setting its position, loop through everything, and increment the X offset based off of the width of the segments, kind of similar to how we do our sprite string rendering. Rotate the end so that it's facing towards the segments, update its position, render it, and then render the tick, and then render the sprite string. Deregistry, do edge drawable, and remove from canvas. And that's it.